Everyone knows the Great Wall of China. Millions of tourists climb its stones every year. Its silhouette is stamped on postcards, textbooks, and movie posters. It is, in the popular imagination, the ultimate symbol of ancient defense. But 1600 years before drones could photograph it from orbit, a different empire built a different wall, one that stretched nearly 200 kilometers across a windswept plain at the edge of the known world. It was built from millions of fired red bricks. It was studded with massive forts. It was fed by a canal engineered to run water across an entire frontier. Thousands of soldiers once walked its length, watching a horizon that could at any moment fill with horsemen. Archaeologists who have surveyed it call it one of the greatest engineering achievements of late antiquity, a project that, in scale, rivals anything Rome or China ever attempted. So why has almost nobody heard of it? No blockbuster films, no crowds of tourists, no postcards, just a low red ridge, half buried in the grass of northern Iran, quietly waiting for someone to ask what it once was. To understand why this wall exists, we first have to understand the enemy it was built to stop. By the 5th century, the Sasanian Empire ruled one of the richest territories on earth. Its cities overflowed with silver, silk, and grain. Its engineers built dams that still function today. Its kings claimed descent from gods. But wealth like that draws attention. Along Persia's northeastern frontier, the empire's rich provinces thinned out into open steppe, a border with no mountains, no rivers, no natural wall to hide behind. And on the other side of that border lived some of the most feared horsemen in the ancient world, the Hephthalites, a nomadic power historians often call the White Huns. They did not fight like Roman legions or Persian infantry. They struck without warning, riding in fast from the open plain, hitting a target, and vanishing before a response could ever be organized. A fortress built in one place could not stop an enemy who simply rode around it. A frontier without a wall was a frontier with 1,000 open doors. For Persia's kings, this was not a distant threat. Hephthalite armies had already humiliated Sasanian forces in open battle, and at least one Persian king is recorded as having died fighting them. The message was unmistakable. The old ways of defending a border were no longer enough. Something new was needed. Something that didn't rely on catching the enemy, but on stopping them from ever choosing where to strike. The obvious answer might seem simple. Raise a bigger army, station more soldiers on the frontier. But that solution had a fatal flaw. The border was too vast, and cavalry could strike at any single point along it. Spreading soldiers evenly across 200 kilometers of open ground meant that everywhere was defended a little, and nowhere was defended enough. An army large enough to guard every possible crossing would have bankrupted even Persia's wealthy treasury. And still, a fast-moving raiding party could slip through before word ever reached the capital. What Persia's engineers and generals needed instead was a way to control movement itself. Not to chase the enemy across the plain, but to funnel them into places where Persian soldiers could see them coming, react in time, and hold the line. The answer would not be an army. It would be architecture, a permanent barrier that turned an unguardable, open frontier into a single, defensible edge. Every great defensive project begins with a map, and this one begins with the sea. To the northwest lies the Caspian Sea, an enormous natural barrier no cavalry could cross. To the southeast rise the Alborz Mountains, a jagged wall of stone that horsemen could not easily ride through. Between these two natural obstacles lies a corridor of flat, fertile land, the Gorgan Plain. It is here, and only here, that the open steppe narrows into a bottleneck, a strip of land perhaps 180 kilometers wide, hemmed in by sea on one side and mountains on the other. Anyone riding from the steppes toward Persia's rich interior had to cross this exact stretch of ground. Persian engineers recognized what this geography meant. They did not need to defend the entire frontier. They needed to defend this single corridor, and if they built a wall exactly here, sea and mountains would do half the work for them. The Gorgan River itself, cutting across the plain, offered something else, a ready source of water. And so the wall's builders chose to follow the river's course closely, letting the landscape itself dictate the shape of their creation. Geography did not just influence the defense system, it became part of it. Stand today on the low mound that remains, and it is hard to imagine what once rose from this ground. But the archaeological record allows us to reconstruct it. The wall likely stretched close to 200 kilometers, built largely of fired red brick, a striking choice in a region where most fortifications used mud brick or packed earth. Sections are estimated to have reached several meters in height, wide enough for patrols to walk its length. Along the way, dozens of massive rectangular forts were built directly into the wall's line, their brick walls glowing dull red under the sun. A ditch ran alongside sections of the barrier, deepening the challenge for any rider attempting to cross. And running parallel to the wall, engineers dug a canal, turning the whole structure into far more than a simple barrier of stacked brick. It is this reddish color, stretching for 195 kilometers across the plain, that has earned the site its modern nickname among archaeologists, the Red Snake. Picture standing on top of it in the 5th century, brick beneath your feet still warm from the kiln, forts rising every few kilometers like knuckles on a closed fist, the canal glinting beside you, and beyond it, the open grassland stretching toward a horizon where danger could appear at any hour. But how do you even begin building something on this scale? That is where the real mystery begins. This is where the story stops being about a wall and becomes a story about human ingenuity. Before a single brick could be laid, Sasanian surveyors had to solve a problem that would challenge modern engineers, marking a nearly straight line across almost 200 kilometers of uneven terrain, without satellites, without modern instruments, without aircraft to check their work from above. The likely method, based on comparable ancient engineering projects, involved sightlines, teams working with poles, ropes, and fire or smoke signals at night to keep each new section aligned with the last. Surveyors would have worked in relay, checking each other's progress across the horizon, correcting drift before it could compound into miles of error. The final result runs remarkably straight for its length, suggesting a level of surveying discipline historians once assumed belonged only to Rome. Once the route was marked, the true labor began, brick production on an almost unimaginable scale. Archaeological surveys have identified numerous kiln sites positioned directly along the wall's route. Not a coincidence, but a deliberate manufacturing strategy. Rather than transporting finished bricks across vast distances, Sasanian planners brought the factories to the wall itself. Clay was dug from nearby riverbanks and fields, mixed, shaped in wooden molds, and dried before firing. The kilns, built from the very brick they produced, could reach the high temperatures needed to harden clay into the dense, weather-resistant red brick that still survives in fragments today. Estimates drawn from the wall's surviving volume suggest hundreds of millions of bricks were required, a production effort that would have run continuously for years. Foundations came next. Excavations revealed that builders often laid a base of rubble or packed material before beginning brickwork, spreading the load and protecting the wall from the shifting, occasionally marshy ground of the plain. Bricks were then set in courses, layer stacked on layer, bound with mortar, likely a mixture of clay, gypsum, or lime depending on local material. A formula that has allowed sections to survive over a millennium of wind, rain, and neglect. Moving material was its own enormous challenge. Ox-drawn carts almost certainly carried brick and clay along temporary roads beside the construction line. Where the parallel canal was already functional, flat-bottomed boats may have ferried material more efficiently than carts ever could, turning the canal into both a water source and a supply road, moving south to reach at once. Lifting brick to height would have required timber scaffolding and simple wooden hoists, cranes using rope, pulleys, and counterweights, technology well within the reach of an empire that had already built irrigation systems and monumental palaces elsewhere in Persia. None of this could function without organization on a scale most ancient societies never attempted. Thousands of workers, conscripted laborers, skilled brickmakers, military engineers, and overseers had to be fed, housed, and coordinated across a construction line stretching further than the distance between many modern capital cities. Local governors likely managed separate sectors, each responsible for a stretch of wall, reporting progress and coordinating brick supply along a chain of command that could stretch the length of the entire project. Quality control mattered too. Surviving brick sizes are remarkably consistent along much of the wall's length, suggesting standardized molds distributed to kiln sites, not each community improvising its own dimensions. This uniformity is one of the clearest fingerprints of centralized planning. Weather would have dictated the working calendar. Brick firing and the drying of clay both demand dry conditions, meaning construction seasons were likely concentrated around drier months, with winter used for material preparation, planning, and kiln maintenance rather than active building. Given the scale of the undertaking, many archaeologists estimate the wall's construction unfolded over years, possibly a decade or more, involving a workforce that may have numbered in the tens of thousands at peak activity. Soldiers and civilians, craftsmen and laborers, all moving toward a single staggering goal. Every stage of this process, from the first surveyor's sightline to the final brick laid in the final fort, represents ancient logistics working at the edge of what pre-industrial civilization could achieve. Alongside almost every kilometer of wall runs a second feat of engineering, easy to overlook and impossible to overstate: the canal. Diverting water from the Gorgan River, this channel did far more than decorate the frontier. It supplied the enormous quantities of water required for brick production, mixing clay, cooling kilns, sustaining the workforce that lived and labored along the line for years. It doubled as a transport route, allowing boats to move brick, tools and supplies faster than any ox cart could manage over rough ground, turning a construction project spanning 200 kilometers into something logistically manageable. Where it ran beside the wall itself, the canal functioned as an additional obstacle, deepening the barrier facing any cavalry attempting a crossing, adding a wet, difficult approach to an already imposing structure. And beyond construction and defense, the canal likely irrigated fields along the frontier, allowing agricultural settlements to take root in support of the garrisons, communities that could feed the soldiers stationed along the wall without relying entirely on supply lines stretching back to Persia's interior. In this way, the canal transformed a line of brick into a complete self-sustaining system, one that could feed itself, supply itself, and defend itself long after the last kiln went cold. Roughly 40 forts have been identified along the wall's route, positioned with what appears to be careful strategic spacing, close enough that neighboring garrisons could support one another, far enough apart to cover the ground efficiently. Within these walls stood barracks capable of housing significant garrisons, supply depots holding grain and equipment, and armories stocked for sustained defense rather than a single skirmish. Communication between forts would have relied on signal towers, smoke by day, fire by night, a language of light and haze that could carry a warning across kilometers faster than any rider. Horse messengers filled the gaps signals couldn't cover, carrying detailed reports between garrison commanders and, ultimately, back towards Sasanian regional authorities. Together, these forts did not function as isolated outposts. They worked as a single distributed machine, one system of eyes, messengers, and reinforcements spanning the entire frontier, capable of reacting to a threat almost anywhere along the line within hours rather than days. Picture an ordinary morning along the Gorgan frontier. Before sunrise, patrols set out along the parapet, checking sightlines toward the plain as the sky lightens. Guards change at the forts in careful rotation, exhausted soldiers handing their post to fresh replacements, while officers inspect equipment and confirm the night had passed without incident. Elsewhere along the wall, life carries on in a rhythm far removed from combat. Blacksmiths hammer out tools and repairs. Brickmakers continue their endless work at kilns that never fully go quiet, replacing worn sections and expanding new ones. Engineers inspect stretches of wall for erosion or storm damage, planning repairs before small cracks become collapsed sections. Soldiers drill in open ground near the forts, practicing formations meant to hold a line against cavalry rather than face them in the open. Officers oversee training and manage the constant logistics of feeding a garrison stretched across 200 kilometers. Around the forts, small communities of merchants and families settle nearby, drawn by the steady presence of soldiers with wages to spend and mouths to feed. Markets form. Children grow up within sight of Persia's greatest frontier project, treating the towering red brick as simply the backdrop of ordinary life. For most of its existence, this was not a battlefield. It was a working frontier, alive with routine, labor, and the quiet tension of watching a horizon that could, without warning, change everything. When the horizon did change, the entire system was tested at once. Cavalry scouts would be the first warning. Distant riders spotted from watchtowers, dust rising from the plain long before any details could be confirmed. Signal fires and smoke would carry the alarm from fort to fort faster than any single messenger could travel. alerting garrisons along the threatened stretch of wall within a remarkably short window. Soldiers would take position along the parapet and within the ditch, using the wall's height and the canal's obstacle to blunt the effectiveness of a cavalry charge that depended entirely on open ground and speed. Neighboring forts, alerted by the same signals, could dispatch reinforcements along the frontier road, concentrating force at the exact point of danger rather than spreading soldiers thin everywhere at once. Did the system work? The archaeological and historical evidence suggests real success for generations. The wall likely deterred and disrupted raids that might otherwise have devastated Persia's northeastern provinces, buying the empire decades of relative security along a border that had once seemed impossible to defend. But the wall was not without weaknesses. Any barrier of this length required constant maintenance, a garrison large enough to be meaningful everywhere, and central authority disciplined enough to keep the whole system funded and coordinated. It was a solution built for a particular threat, in a particular era, and when the political and military landscape shifted, so did the wall's usefulness. Empires do not last forever, and neither do the defenses built to protect them. Over time, the nature of the threat along Persia's northeastern frontier began to change, and the resources needed to maintain such an enormous system became harder to justify. The Sasanian Empire itself, weakened by internal strife and a series of costly wars, entered a period of decline in the early 7th century. Then came the Islamic conquests, which would ultimately end Sasanian rule entirely. As the empire that built and maintained the wall disappeared, so did the political will and organized labor required to keep such a massive structure functional. Without garrisons to patrol it, without engineers to repair it, the wall began its slow surrender to nature. Wind and rain eroded exposed brick. Local communities, no longer bound to protect the structure, quietly began repurposing its bricks for their own homes and buildings, a practical reuse of material that, piece by piece, dismantled a monument 2 centuries in the making. Within a few hundred years, one of the greatest engineering projects of late antiquity had faded into little more than a low red ridge across the Gorgan plain, its origin and purpose slowly forgotten by nearly everyone except the land itself. For centuries, the wall existed mostly as a curiosity, a strange linear mound that local farmers and travelers noticed but rarely questioned. Modern archaeology changed everything. Aerial photography and later satellite imagery revealed what could never be fully appreciated from the ground, a continuous line stretching for nearly 200 kilometers, its scale only obvious from far above the earth. Systematic excavations, particularly research conducted from the 1970s onward and expanded significantly in the 2000s, uncovered kiln sites, fort foundations, and sections of the canal that confirmed the wall's true purpose and scale. Radiocarbon and thermoluminescence dating of fired bricks placed the bulk of construction firmly in the Sasanian period, resolving a long-standing debate about who actually built it and when. Each new excavation season has added detail, refining estimates of the workforce, mapping additional forts, and revealing just how sophisticated Sasanian frontier engineering truly was. What was once dismissed as a minor curiosity is now recognized by archaeologists as one of the most significant frontier defense systems ever constructed. Place the Great Wall of Gorgan beside history's other legendary barriers, and it does not shrink in comparison. The Great Wall of China stretched across a vastly larger territory, built and rebuilt across many dynasties over centuries. Hadrian's Wall marked the northern edge of Roman Britain, a stone line barely a fraction of Gorgan's length. The Theodosian walls protected a single city, Constantinople, rather than an entire frontier. The walls of Babylon guarded an ancient capital with baked brick and towering gates. Each of these was extraordinary in its own right.
Riders!
But few were built as quickly, across such difficult terrain, with a canal system integrated so completely into the defense itself. In sheer engineering ambition, the Great Wall of Gorgan belongs in that same company. A peer to the most celebrated defensive projects in human history, even if the world has only just begun to remember it. Empires fall. Cities disappear. Kings, so certain of their own permanence, are eventually forgotten by name.
This is the crossing point, engineer.
But somewhere on a windswept plain between a sea and a mountain range, red brick still holds its line, a quiet reminder that even when everything else fades, great engineering keeps telling its story, waiting patiently for us to notice.